Hello, for this lesson we're going to talk about derivatives of functions. So we saw derivatives at a point, now we're going to talk about derivatives of the function. So that's our big goal here, is to define the derivative function of a given function. So instead of this, you've seen this before, it's that difference quotient, but instead of it being a point a plus h, f of a plus h minus f of a all over h, now it's f of x plus h minus f of x all over h. And before, when we had two different versions that we could look at to find the derivative at a point, this one we only have the one. So let's go forward and take a look at this. Find the square root, the derivative of the square root function. So f of x equals the square root of x. Does not want to do blue today, does it? Okay. So it says find the derivative of f of x equals square root of x. So we're going to look for f prime of x, which is going to be the limit as h goes to 0 of f of x plus h minus the f of x all over h, which will become the limit as h goes to 0 of the square root of x plus h minus the square root of x all over h. Now, to deal with a radical, like a difference radical, even if you had a radical minus a number, you still do the same thing. So we're going to multiply this by the conjugate, which is the square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x. Every color but blue. Okay, so that's going to be the limit as h goes to 0 of, now that's an x square root of x plus h minus square root of x times square root of x plus h plus square root of x. So that's like an a minus b times an a plus b. So we have x plus h minus x over h times the square root of x plus h plus the square root of x. Now the numerator becomes the limit as x, or as h approaches 0, of h over h times the square root of x plus h plus square root of x. And these h's will divide out. So our numerator becomes one over the square root of x plus h plus square root of x. Now as h goes to 0, this would be 1 over the square root of x plus 0 plus the square root of x, which is 1 over the square root of x plus the square root of x, or 1 over 2 times the square root of x. And that's it. Kind of fun, huh? Let's try another one. Find the derivative of the quadratic function. So I got a little more space I can work with up here. So we're going to look at the limit again as h goes to 0, looking for f prime of x. F prime of x. Of f of x plus h minus f of x all over h. So that's going to be the limit as h goes to 0 of x plus h squared minus 2 times x plus h. Then we have a minus the original thing, x squared minus 2x all over h. Now we need to expand the binomial, and we'll have the limit as h goes to 0 of x squared plus 2xh plus h squared minus 2x minus 2h minus x squared plus 2x. Distributing that negative all over h. So we have the limit as h goes to 0. Now this is kind of fun. Things start canceling out. The x squareds go away. And this 2x here goes away with that one. And this leaves us with a 2xh plus h squared minus 2h all over h. And like I said, for the ones we did for the point, those h's, everything should have an h left in it so it can divide out with the h down below. We have the limit as h goes to 0. That is for polynomials anyway. And you can divide an h out of every term, so you have 2x plus h minus 2. If you divide the h out. Now if you apply the limit, you end up with 2x plus 0 minus 2, or 2x minus 2. That's it. That would be the derivative of x squared minus 2x. Let's try another one. This one's not so bad because it's actually just an f of x equals x squared. So here we would have f prime of x is going to be equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. That's going to be the limit as h goes to 0 of x plus h squared minus x squared all over h. So we have the limit as h goes to 0 of x squared plus 2xh plus h squared minus x squared all over h. And once again, those x squareds are going to go away. Everything left behind has an h in it. So we have the limit as h goes to 0 of 2xh plus h squared over h. That gives us the limit, if you divide the h out, as h goes to 0 of 2x plus h. And as h goes to 0, then you just have a 2x plus 0. So the derivative is 2x. Fun times. Now let's try another one that has a fraction in it. So make sure I didn't skip one. No. Okay, we have f of x equals 6 over x. Find f prime of x using the limit definition of the derivative. So once again, we're going to have the limit as h goes to 0 of 6 over x. Nope, let me back up. I'm jumping steps. Of f of x plus h minus f of x all over h. So that's going to be the limit as h goes to 0 of 6 over x plus h minus 6 over x all over h. So we have the limit as h goes to 0. The deal is we had to get these two to have the same denominator. So I'm going to multiply the one on the right by the x plus h over x plus h, one on the left by x over x. So now we would have six x over x times x plus h minus 6 times x plus h over x times x plus h over h. And we distribute through, we have the limit as h goes to 0. By the way, we have the same denominator now, so we'd have a 6x minus 6x minus 6h. I am combining these numerators, and that's subtracting the second one and distributing that second one. X times x plus h all over h. So we have the limit as h goes to 0. The 6x's will go away. They subtract out. No, 0. This isn't dividing. And what's interesting here is that we have this negative 6h over x times x plus h. Now, remember, this has all been divided by the h every time, so I could write this as times 1 over h, which is the same thing as dividing by h. In fact, let me do that in another step. Let me write this instead as divided by h, because this becomes the limit as h goes to 0 of negative 6h over x times x plus h times, so divided by numbers by the same as multiplying by its reciprocal. And now these h's would divide out. There's where I could put my 1's. So I get rid of that there. Okay, so what do I have? I have the limit as h goes to 0 of negative 6 over x times x plus h. And now I don't have a problem if I plug in that 0. I could have negative 6 over x times x plus 0, which is negative 6 over x squared. That's it. Okay, moving along. So here we're seeing this familiar graph where dy dx is the limit of the change of y over the change of x. So this is our change of y, change of x. As that change of x goes to 0, so if the change of x goes to 0, we get the change of y over change of x at a specific point, not over an interval. So the derivative expressed as dy over dx, this is the notation we use, one of the notations. We can also use f prime of x as another one, and sometimes y prime. Anyway, this is the limit as delta x goes to 0, delta y over delta x. And that's it for this section.